Okay, very good morning to all of you, my dear students and my dear colleague present over here. Already you have completed most of the experiments. I am sharing the syllabus. Then it will be better to understand how many experiments we have completed. Okay. So, is it visible to all of you? The screen is visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So, experiment 1, 2, 3, 4, 5, 6, 7, 8, up to 8, you have completed. Am I right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So this is the last experiment in your syllabus. Number 9, measurement of power in a 3-phase unbalanced circuit by 2 wattmeter method. So basically you are acquainted to measure the 3-phase power using 3 wattmeter method, but we will do here 2 wattmeter method. I think you are acquainted with the theory in your theory class. How can you measure the 3-phase power using 2 wattmeter? Basically, if you don't use 1 wattmeter, 1 hour wattmeter, then it will be easier to measure using 2 wattmeter. You can escape 1 wattmeter. This is the advantage of this experiment. So I think you will have an idea regarding the star connection and delta connection if you want to perform this experiment. So do you have the idea regarding star connection and delta connection to measure the current and voltage in this connection?
Yes, ma'am.
Yes, ma'am.
So anybody can tell me what is your idea in case of delta connection and star connection? If you consider star connection in 3-phase, then what will be the relationship between the phase current and line current?
Ma'am, in
Equal.
star connection, I line is equal to I phase and the line voltage is equal to √3 times of phase voltage. And in delta connection, line voltage is equal to phase voltage and line current is √3 times of phase current.
So your idea is clear, or I will explain, I will just recap.
Clear, ma'am.
Okay, I am giving a recapitulation during this one, and then we'll go to the measurement of power in the virtual lab. Okay. So voltage, today's date is 02/02/2022. Each and everybody has copy? Do you have copy?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Everybody
Yes,
will
ma'am.
write it. Voltage and current in Y connection. You are writing, dear students?
Yes, ma'am.
Y means star connections. Okay. So this is the basic thing before going to measure the power using wattmeter. So this is a 3-phase come. Basically, what is happening? I think you have got the idea like this. Okay. Right now?
Yes, ma'am.
3-phase. But actually, if you consider this, these are 3 coils, 1, 2, 3. And this is the start, this is finish, this is start, this is finish, start and finish. These are the start to finish of these 3 coils. This is 3-phase. They are separated by an angle. What? What is the angle?
120 degree.
120 degree.
120.
Yeah, very good. So this is, say, R, B, Y. So if you consider the current in case of this one, this is one phase. say R phase, this is B phase, this is Y phase. Okay. So if you want to measure the line current, so if you want to measure the current, what you have to apply? You have to apply an wattmeter. I'm sorry, ammeter. Am I correct?
Yes, ma'am.
So this is the line. Use an ammeter here. So this will give the current. Okay. So if you consider this one, this is basically a particular loop. Okay. So the current passing through each phase and each line, is it same or not? From this, is it clear?
Yes, ma'am.
Ishita, what I have told, that if you consider this loop, then the current will flow. This will be equal in phase and in line.
Yes,
Am I
ma'am.
correct?
Yes, ma'am.
Hence, in this star connection, we can tell that I phase, that is equal to I line current. Now it is clear why I line current and I phase, I mean current, line current and phase current, both are equal in case of star connection. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So if you want to measure the voltage, then what to do? This is a phase. This is a phase. So if you want to measure the voltage between VRB, okay, then what to do? Say this is R, B, Y. In this case, phase voltage and line voltage is equal.
No, ma'am.
No, ma'am.
No, ma'am, no.
No, ma'am.
So why not? Basically, this is a particular phase and this is a particular phase. So if you want to measure the voltage between two phases, definitely the phase voltage will not be equal to the line voltage. Okay. Line means say VRB. So if you consider like this, say this is VR, this is VB, and this is VY. So draw like this. This is minus VY. Okay.
Now in the phasor diagram we have to draw like that.
Sorry.
In the phasor diagram we will draw like that.
I didn't get your voice. Please, can you repeat?
Ma'am, I am saying that in the phasor diagram we will draw like that. No.
Yeah,
I
yeah,
mean-
yeah. Yeah, very true. So this is VRY. Can I tell this, Ishita? I think you are Ishita, right?
Ipshita.
Ipshita. VRY.
Yes,
Yes.
ma'am.
So what is the angle between this?
60 degree.
60 degree, correct. 60 degree. Okay. So
Yes, ma'am.
from the law of parallelogram, you know this law? Do you know this law?
Yes, ma'am.
Yes, ma'am.
If this is phi, say this is A, this is B, and if this is the resultant one, the what will be the resultant? R square, that will be equal to,
A square
okay,
plus
A square plus B square,
plus
Cos
2AB
phi.
cos phi.
AB cos
2AB
phi.
cos phi.
Yes, ma'am.
Am I correct?
Yes, ma'am.
Okay. So apply this law here. So what will be VRY? That is the line voltage.
Root over of VR square plus VY square plus 2 VR.
Yes,
VY
very
cos
true.
60.
VR square plus VY square mod value, basically VR VY cos of 60 degree. Am I correct?
Yes, ma'am.
So in this case, what is happening? VR equal to VY, that is equal to VV, that is V phase. So you can write this V phase square plus V phase square plus 2 into V phase that into cos of 60 degree. Fine. So what is you are writing?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, thank you. So 2V phase square plus 2V phase square into cos 60 means half.
Half.
Yeah, 2 cancel out. So it will give what?
3.
Root 3 V
3 V
phase.
phase. Root
V
3
V
phase.
phase square. Fine.
Yes, ma'am.
So V line that will be equal to what?
Root
Root
3.
Root
3 V
3
phase.
V phase square.
So this is the concept in case of line
Star.
current and line voltage.
Yes,
In
ma'am.
case of star connection, I think it is very clear to all of you.
Yes, ma'am.
Okay. Now go to delta 1. So you will write in your copy the V line current that will be equal to V root 3 V phase in case of star connection, and I phase that will be equal to IL in case of star connection. Have you noted it?
Yes, ma'am.
Yes, ma'am.
So go to the another
Yes,
one,
ma'am.
that is the delta connection. Okay. So 1, 2, 3. These are the 3 phases. So this is represented by I. So this is B and this is C. I'm sorry, delta connection.
Star.
Okay. It is star connection. So this will be like this. Oh, now it is okay.
Yes, ma'am.
So just extend these 3. So this is point A, this is point B, this is point C. Say this is IR. So this is IY. So this is IB. Okay. Now, if you want to measure the potential, that is the voltage between 2 phase, what will happen? You
It
will
will
give a
same.
Line voltage.
voltmeter here.
Yes, ma'am.
And if you want to measure the current between 2 phase, say this is ammeter. This is ammeter. Measure 2. You want to measure the current between 2 phase, this phase and that phase. Okay. But in this circuit, that is delta connection, current IY will be here, IR will be here. So exactly IR not will be equal to IY in this case.
Yes, ma'am.
But in this case, if you want to measure the potential between these 2 points, then what will happen? The phase voltage
Will
and
be
the
equal to
line
line
voltage will be same.
Yes, ma'am.
Is it clear?
Yes, ma'am.
V, this is a phase. Say this is Y phase, this is Y phase, this is B phase. So these are connected to this point, 2 phases are connected to that point. So in this triangular form, if you want to know the potential difference between 2 phases, that is the line voltage, that is VL, that will be equal to definitely V phase. But in case of delta connection, if you want to get I phase and IL, is it equal?
No, ma'am.
No, ma'am.
No equal, not directly, because in this case, IY is coming, IB is coming. So in this case, the same thing will happen. You have to say IY, IB, IR like this, and this is the resultant. Okay. Fine.
No.
So what will happen? IL will be equal to what? Root 3 I phase in case of delta connection.
Yes, ma'am.
And VL will be equal to V phase.
V phase.
Clear? So in case of delta connection, IL that is equal to root 3 V phase, VL that is equal to V phase. But in case of star connection, what we have got? IL that is equal to I phase.
I phase.
And
VL equals to
VL
root 3
that
V
is
phase.
equal to
Root 3 V phase.
root 3 V phase. So up to this clear. Now what is the power? Power equal to what? 3 into I phase into V phase.
V phase, I phase, cos phi. Yes, ma'am.
Yeah. So what is I phase? In case of star connection, I am considering star connection. I phase that is equal to IL. V phase equal to what? VL by root 3.
VL by root 3.
Okay. So what is the formula you are getting? Root 3 VL IL. So this power you want to measure using the wattmeter. That power equal to root 3 VL IL. Fine?
Yes, ma'am.
Yes, ma'am.
Okay. Now come to another theory question. That is the power factor angle. You consider this one. Sorry. Power factor. And before going that, we will consider star connection and power measurement. Okay. Definitely you can measure the power in case of star or delta. Right, Ishita?
Yes, ma'am.
So this is Anipshita, are you there?
Yes, ma'am.
Everybody's understands what I have telling you?
Yes, ma'am.
Yes, sir.
Yes,
Clear?
ma'am.
So this is the wattmeter current coil. This is the wattmeter pressure coil. Okay. This is the wattmeter. And again, come here. This is another one. This is wattmeter, current coil, pressure coil. This is another wattmeter is there. So this is say A. This is IA. This is IB is there. This is IC is there. Definitely this is star connection. Load A, load B, load C. Now go there. This is C. Already I have told you from in the beginning of our class. This is B. 3 lines. Okay. So this is the wattmeter. 1 wattmeter is connected and 2 wattmeter is connected. So this is W1, this is W2. So 2 wattmeters are connected here. So how can you tell that using 2 wattmeter you are able to measure 3 phase power? So you have to show that right now. এখানে আমরা কি করেছি? 2 wattmeter we have used in 2 phases. Okay, this one and that one. So this is only 2 wattmeters are enough to measure the 3 phase power. So how can I show it? So for wattmeter 1, the instantaneous current through the current coil is IA. Right now?
Yes, ma'am.
Am I correct?
Yes,
Yes, sir.
So
Yes,
for
ma'am.
wattmeter 1, the instantaneous current through it that is equal to current coil is IA. And the instantaneous voltage across its pressure coil is what? EAC. EAC. Right?
Yes, ma'am.
Similarly, in case of wattmeter 2, the instantaneous current, that is IB, and what is the voltage according to the pressure coil? That is what?
EBC.
VBC. Fine.
VBC, yes.
So instantaneous power in case of W1, what will be? Ipshita, what is the instantaneous power? Current
IA,
into voltage?
yes,
IA
into VAC.
that is, we can tell like this, EA minus EC.
EA minus
Yes,
EC.
yes, ma'am.
Yeah. And W2, what will be? IB
into EB
EB
minus EC.
VB minus or EB minus EC. Fine. So what is W1 plus W2? IA EA minus EC plus IB
EB minus
EB
EC.
minus
EB
EC.
minus EC. Fine. So what will you get? IA EA minus IA EC plus IB EB minus IB EC. So what is happening? IA EA plus IB, EB minus IA. If you take common EC, it will give IA plus IB. Okay. Now, from using KCL, what is happening? Ashita, if you apply KCL at this point, then what will happen? What will happen regarding IA, IB, IC?
Ma'am, they'll be same.
IA plus IB plus IC, that is equal to 0.
Zero. Yes, ma'am.
Right? Because
Yes.
sum of, if you consider a particular node, then the sum of current entering or that is leaving will be 0. Fine now?
Yes, ma'am.
So IA plus IB, that is equal to minus
Minus
IC.
IC.
Minus IC.
Fine. So if you put here, what will you get? IA EA
Plus IB.
plus IB EB minus EC into what? Minus IC.
Minus IC. This should be plus ECIC.
So ultimately you are getting what? IA EA plus IB EB plus EC IC. So these are three power, that is PA, PB plus PC. That is the total power.
Yes, ma'am.
Fine now?
Yes, ma'am.
Yes, ma'am.
So using 2 wattmeter, you are able to measure the 3-phase power. So you can skip 1 wattmeter, right? And
Yes,
already I
ma'am.
have told you what is total power. That is our motto. Total power. Anybody can tell me total power? Already I have told. 3 into
VL IL cos phi.
3 into phase power. That is 3 into
V phase.
V phase
Phase I phase.
cos phi.
Yes, ma'am.
So what is V phase?
VL by root 3.
EL by root 3.
Fine. It's not written over here. 3 into VL by root 3 into I phase equal to IL in star.
Yes,
So
ma'am.
ultimately what you are getting here?
Root 3 VL IL cos phi.
Root 3 VL IL cos phi. This is the formula you have to use in our experiment. Fine. Now another one is there, that is power factor angle. This is the last one, okay? So come to power factor angle. Consider star connection. say this is R, this is B, this is Y. So this is VR represented by this is VB, this is VY, fine. So just like this, minus VY. Just I'm considering one set, okay? This is the resultant one. This and this. So this is obviously VRY. And I'm sorry, if you consider, okay, just I'm drawing the full VB and VR is here, minus VR. This is B. So minus VB. So this is the resultant here. This is the resultant here. And yeah. Here, here, VY, VB, yeah. This is the resultant here. Okay, this is V, BR. Okay, fine. Now consider the current, because these are, you have to consider the generator, right? And this is the inductive coil is there. So you have to consider this is inductive load. So in case of inductive load, what will happen? The current will be phase difference, I mean phase lag with respect to the voltage. Am I correct?
Yes, ma'am.
So consider here like the VR, say this is your current, so this is phi, okay? And this is 60, total 60, and obviously this is 30 degree. Am I correct?
Yes, ma'am.
30
Yes,
degree, and this is phi, this is VR, and this is VB respected, that will be, I'm sorry, that will be also, that will be phi here, and here it will be again phi. This is again phi. That is, this is IR, this is IB, this is IY. So if you consider this one, anyway, one will be 30 plus phi, and another will be say VIB cos of 30 plus phi, okay? So if you consider this one, VRY, that is equal to what? V line. So V line equal to what? Am I audible?
Yes, ma'am, I was saying that Ipshita was right. If we take minus VB and VR, ma'am, then we are getting 30 plus 5.
Yes.
That triangle, that parallelogram.
Can I share?
V line, that is equal to root 3 V phase.
Yes, ma'am.
Root 3 V phase into IR, that is equal to I phase. Okay. Cos of 30 minus 5. And in case of W2, what will happen? In case of W2, it will be root 3 V phase.
I phase cos 30 plus 5.
Root 3 V phase, I phase, cos of 30 plus 5. Okay. Now, cos of A plus B, what is the formula? Cos of A plus B, what is the formula, Ipshita? Cos A cos B minus sin A sin B.
Minus sin A sin B.
And so you have to use the formula. And in case of cos of A plus B, cos A cos B, I mean minus sin A sin B, cos of A minus B, cos A cos B plus sin A sin B. So using these two formula, ultimately you will get what? W1 plus W2, that will equal to what? Root 3 V phase, I phase
Cos 5.
into
Cos 5.
Into root 3 by 2 cos phi. So this will give 3 V phase, I phase, cos phi.
Yes, ma'am.
Yes, ma'am.
By 2.
Yes,
By
ma'am.
2.
By 2.
There was another 2 were there. If you calculate it, it will be cancelled out. Okay.
Cancel.
So 3. So what is V phase? What is V phase? Anybody?
VL by root 3.
PL by
VL by root 3 into I phase means IL in star
IL.
connection. So it will give root 3
VL
VL
cos phi.
IL cos phi.
Yes, ma'am.
So this is the total power in case of 3-phase power. And already I have seen that 3 into V phase I phase cos phi in case of 3-phase power, that will give root 3 VLIL
Cos phi.
cos phi. So these are same to this. Okay. So these are the theory portion. Now we will come to the this is the 3-phase power measurement. And do you want the link?
Yes, ma'am.
So I am sharing the link in chat box. This is the link for 3-phase power measurement. Now come here. Using this link, I have got this. So this is the theory portion. Already you have explained very well. How can you get this? Here, this is here. VBY. This is 30 minus 5. Okay. And here is the concept 30 plus 5. What they have written over here, VBY, VRY, and VYB. But there will be, okay, where is VR? Where is VR here? Here, VRN with respect to neutral, VRN, VYN, and VBN. Fine. And this is a resultant, that is VBY. And if you consider the angle phi, IBN, yes, what I have told you, that first one will be this here, okay?
Yes, ma'am.
First one will be here. That is the away from resultant, fine? And second one will be this one. This is away from resultant means this will be 30 minus, if you consider the power, then it is 30 degree. And this is total phi. So it will be 30 minus 5 minus 30, whatever. Because phi is greater than 30. Okay. So
Okay,
5 minus
ma'am.
30. And here what is happening, IRN, this is phi. So this will be 30. This is VRN. This is phi. So this is 30 plus phi. 30 plus phi. Okay. Fine. Then you will be able to get 30 plus phi concept and 30 minus phi concept. Okay.
Yes, ma'am.
Okay. Now come to the simulator part. Simulator. So what is happening here? Root 3 VLIL cos phi. Okay. And here this is the resistive load. The phi will be 0. That is cos phi will be 1. Set the 3-phase voltage 100 volt at frequency 50 hertz. Frequency 50 hertz. Okay, fine. Set the balanced load value. This is 25, 25, 25, no problem. Resistive load is here. And switch on the supply to get the meter reading. Switch on the supply. So wattmeter 2, wattmeter are here. Wattmeter 1 and wattmeter 2. So this will give the reading. What is the wattmeter 1 reading? 199. Wattmeter 2 reading, so approx 200. And this is 2, that is 400. Okay. And if you consider VLIL, then it will give the total power √3 VLIL. So put the value of voltage and value of current and cos phi that is equal to 1. Then you will check it.
If we fill the table, then it will come automatically.
Yeah.
All the values. Okay.
All the values. And you have to check whatever you have calculated here, W1 that is equal to VLIL cos of 30 plus 5. Already you have seen. And W2 that will be equal to VLIL cos of 30 minus 5. And phi is here 0. So VL equal to what? 100 volt. And IL equal to what? What is IL? 2.3. And cos 30 that is equal to what? √3 by 2. So 100 into √2.31 into √3 by 2, that will give approx 200 watt. And what is WL? Same, VLIL cos 30 minus 5. So it will give also 200 watt. And if you add W1 and W2, it will give 400. And in this case, you know the total power √3 VLIL cos phi. The cos phi that is equal to 0, phi 0 cos phi 1. So √3 VLIL, √3 VL, IL, VL that is equal to 100 and IL 2.31. So this will give approx 400. So √3 VLIL and W1 plus W2 will give the same value. Is it clear to all of you?
Yes,
And
ma'am.
there is a difference of 100 in WC and WM.
Where?
Oh no, ma'am. Oh, sorry, ma'am. I saw that 300. This is 399. Sorry, ma'am.
So you can change it. VL automatically IL will be changed. So this is the connection and these are the value, how you can get it. And definitely in your offline class, you'll do it in the measurement lab. And I think it will be more clear when you'll do the lab physically, right now?
Yes, ma'am.
Yes, ma'am.
So up to this, it is clear to all of you. How can you get the total power using 2 wattmeter instead of using 3 wattmeter?
Yes, ma'am.
Yes, ma'am.
Okay, anybody has any problem? I think, is it okay? Because already you have gone the theory.
Ma'am,
Yes.
ma'am,
Okay, I
were
am
we not
requesting
supposed to?
Meghna, can you share the virtual lab link to your WhatsApp group, to our WhatsApp group?
Sure, ma'am. Ma'am, I wanted to ask that in the Moodle it is written that we have to check it for an unbalanced circuit. So here we did the experiment for the balanced load.
Whatever I am telling you, you have to submit in that way. Okay.
Okay, ma'am.
Don't worry, Meghna. Okay. What is his name?
Alisa.
Okay, it is done.
Ritiman.
Okay, Ritiman, it is done. Okay.